Okay, so 3, 5, by the end of today, we are going to effectively perform operations with complex numbers. So complex numbers are going to include imaginary numbers, which we have worked with before in Algebra 2. So today is called complex numbers. And a complex number, we are going to write it in this form, a plus bi. So the real part goes first, the imaginary part goes second, and then I asked you to read this over so that you'd remember that I squared is equal to -1. That comes from I is the square root of -1, and if you square both sides, that gives us I squared is equal to -1. That's important to remember because anytime we have I squared, we are going to substitute -1 into the equation. And then something else we're going to do today is identify the real part and the imaginary part. Okay, so the real part of the complex number is A, and the imaginary part is going to be B. Okay, so the imaginary part is B, the real part is A. Okay, and we say that two complex values are equal if the real part and the imaginary part are the same. So in example 1, we're going to find the real part of each number and the imaginary part. Okay, so again, the real part is always going to be equal to your A value, which is going to stand alone. The imaginary part, B, is in front of the I value. So for part A, all you have to do is tell me what the real value is, which is 4, and then the coefficient of I is 9. Okay, don't include the I with it, it is just the number in front. So the real is A, the imaginary B. Okay, and then we're going to do something similar for part B, but if you have division, remember that you have to apply this to both values. Okay, so -6/2 does reduce, so we always want to make sure we are reducing. Okay, so go ahead and fill in what the real part is and the imaginary part. And then you can attempt part A. This is something that you did in Algebra 2. It's also something you saw in the Chapter 3 review packet. Okay, so -3 is your real value and -7/2 is your imaginary. Okay, so just double check those for me, and then after you do A, I want you to try part B. And notice that you do have to write your result in this form, A plus BI. Okay, so I'm going to give you a couple minutes to try those, and then we'll go over them together. All right, let's see how we did. So with the minus, you don't have to write out this step. You can just subtract. That is fine. Okay, but I know some of you are very visual, and I am as well. So for me, it helps to distribute the negative, and then I'll do 6 minus 2 is 4. -5 minus 3 is -8. Again, you don't have to write out that step. You can just simply subtract. 6 minus 2 is 4. -5 minus 3i is -8i. Okay, so I want you to do what works best for you. All right, now here we are going to FOIL. So this was subtraction. If there's no operation, it's multiplication. So with FOIL, 6 times 2 is going to be 12. 5 times 2, this will be negative 10i. 6 times 3i is 18i. I like to do this so I can just add it together. And then the last one is negative 5 times 3, negative 15. I times I is I squared. Okay, if you got here, that is great. Okay, that means you remember how to do your FOIL. And then we do have to go a couple steps further. So earlier, I just reminded you that if you have an I squared, you're going to have to plug in negative 1. So that's exactly what we're going to do here. So a negative times a negative ends up being a positive. You can add 15 and 12 together to get 27. And then we are still writing that in the form A plus BI. All right, you guys can let me know on the next one if you want to try this on your own first, or if you want a little hint to get you started. Yeah.
You want us to write out I squared. I know last year, like, had us like always put negative 1.
Yeah, I do just want to see that substitution. Yeah. Yep. And then what do you guys think about C? Do you want a second to think about it? Do you guys remember how to tackle that? Okay, and you do have to show work for this. Don't just write down that answer. I'm glad that some of you remember. Okay, so I see a couple of you putting down negative 1. That is going to be our final answer, but why? It's an even power, yeah, Cedric. Okay, so if you are rewriting this, you're going to rewrite it with I squared. So this is the step I need to see, is that it's I squared to the 9th power. Okay, so when Kristen is saying, oh, it's an odd, this is the odd power, right? If you cut it in half, so it would be negative 1 to the 9th, which is going to be negative 1. And then some of you may have learned earlier, like, oh, if it's a power of 4, it's positive 1. You can split it up into different ways. Mm-hmm.
So I just did negative 1 to the 9th. I squared.
Oh, no, you can do this. Negative 1 to the 9th. Yep,
Yeah,
you can have that step.
Okay.
I just want to see that there's something for how you got to that 18. Mm-hmm.
Okay, so I don't need that. I just have I squared to the power of 9.
Yes.
Is that okay? And then I just went right to it.
Okay. I'll go for it. All right. What about if it's odd? Do you guys remember if it's odd what we would do?
Say it's in the case 32, the same thing, and then just have an I, whatever.
Yeah. So think of it as the even number times an I.
Yeah.
Right? Okay. So again, you're going to rewrite it in terms of I squared. So 2 times 1 is 32. 16, and then we're plugging in the negative 1. Anything to an even power is going to be 1. 1i is just I. Okay? And no, you don't have to write out like every single one of these. This is to help some of you who maybe need more of a refresher, because we did do this like a year ago. So I know that's been a while. Okay, so anytime you have a negative to an odd power, okay, you are going to get a negative. Anytime you have a negative to an even power, it's going to end up being a positive. All right. Questions for me on this side? So if you don't remember the work with I, whenever you have these, you want to know that you're rewriting with I squared. And you're rewriting with I squared because we know that's equal to negative 1, and so we can simplify. The other place where you have to simplify is if I is in the denominator. So the reason why you don't want I in the denominator is because I is equivalent to that square root of a negative value, and we always want our denominators to be rational when possible, and so we don't want that square root in the denominator. All right, so you have 5 plus 6i divided by 1 minus 3i. The goal is we have to get I out of the denominator. This is an expression, it's not an equation, so we can use multiplying by a value equal to 1 in order to manipulate the bottom of this fraction. Do you know what we have to multiply by to do that? Yeah, good. Yeah, your complex conjugate. Nice. Okay, and then let's do the denominator. So let's see why that is what we're going to multiply by. So you are going to FOIL. Actually, I'm going to give you a moment. FOIL the denominator, FOIL the numerator. I'll come around and check and make sure we're good with FOIL. All right, a lot of these look great. So 1 times 1 is 1. Here, these are going to cancel. Negative 3i and positive 3i. That's why we chose this, because now I don't have any i's. I have an I squared. And it's minus 9i squared. Because negative 3 times 3 is negative 9. So when you plug that in, it becomes a plus. So 10 is your new denominator. Okay, and that's why we chose it. So now we have a numerical value without I in it. Okay, we're still going to FOIL on the top. So first times first is 5. I like to do the inside next. You can do the outside, whichever you like. Okay, and then this becomes 18i squared. 6i times 3i is 18i squared. Again, we're going to be plugging that in. Okay, so 5 minus 18 is a negative 13. Okay, so you can do that all in this step. So this would be negative 18. When you add 5 to it, you get negative 13. 6 and 15 is 21. And then whenever you're doing these, remember the directions for this section. Say you have to write it in that A plus BI form. So our last step is just to separate so we can see the B value and the A value. Okay, so make sure that all of your answers are in that form. Okay, now B, there's several different ways to do this, so I'm going to let you decide and then I'll just come around and check. Okay, there's at least 3 different ways I've already seen today people do this, and they're all correct. Okay, so I thought people multiply by either, you can multiply by 4i over 4i. That works. You can multiply by negative 4i over negative 4i. Or you can multiply by I over I. All of those are correct. Okay? Any of those are going to get you what you need, which is an I squared on the bottom so that you can plug in negative 1. So a lot of people do the opposite of 4i just because we're used to doing the opposites here. So you'd have negative 16i squared. When you plug in negative 1, you get positive 16. If you multiply by 4i, you're just going to get negative 16, which is fine because the signs in the top, they're all going to balance out. So here you're going to distribute to each one of these. So if you do 4 times 3, you get negative, and it's negative. So negative 52i minus 44i squared. You plug in that negative 1, and then this becomes positive 44, negative 52i, and then we simplify. Okay, so we know 4 goes into both of those, so if I divide by 4, 44 divided by 4 is 11, 16 divided by 4 is 4, negative 52 divided by 4, we just did that, so it's 13. This divided by 4 is 4, and then this should be your final answer. Okay, and then like I said, there were multiple ways to do this. If you want to avoid having to do the reducing, if you just multiply by I over I, that's going to give you 4i squared, which will give you a negative 4 in the denominator. Okay, so then when you distribute 13i plus 11i squared, and you plug in that negative 1 here, you'll get a negative 11 plus 13i. So what you'll have to remember is when you divide a negative by a negative, okay, that is going to be a positive. Okay, so these are the same. All right, now let's get ready for some real fun here. Going to have some radicals, some negative radicals, some unsimplified radicals. Okay, so in the first set of parentheses, we have the square root of 63 minus the square root of negative 7. And then in the second set, we have 7 plus the square root of negative 9. When you have a lot of things going on in one problem, I recommend just breaking it down into manageable steps. So the first thing you want to do is you want to simplify the negative radicals. Oops, not an S. Okay, so we're going to simplify negative radicals. And if I make a mistake, I normally make a heart. Or I do have my whiteout pens this year. Okay, so when you're simplifying negative radicals, you just have to keep in mind that the I is going to come out in front. Okay, one thing we want to avoid, which happens sometimes, is you can't just multiply a negative radical by a negative radical and then make it magically positive. Okay, so this property does not work when they're both negative. So the square root of negative a times the square root of negative b does not equal the positive root of a times b. Okay, so you cannot do that. What you can do is the square root of negative a times the square root of negative b is the same thing as taking an I times root a times an I times root b. So we need to just recall that I represents that -1. Okay, and then if we went one step further, I times I would be I squared. Okay, you can multiply square roots together because they have the same root, okay, the same index value. But then that I squared would have to be out in front. Okay, so step 1, and I'm only worrying about this first step. I'm going to make it I root 7 and then 7 plus. Now, if I have I root 9, I'm going to simplify it because it's a perfect square. Because what's the square root of 9? 3. So let's write that as 3i. Okay? Okay, and then you have the choice. You could simplify this now or you can simplify it at the end. I choose to simplify at the end so I can do it all together. And then we're going to FOIL. Okay, so we do have multiplication. So when you multiply a radical by a non-radical, the first times the first is just 7 square root of 63. Okay, so for FOIL, first times first. Okay, the next one I'm going to do is the inside. So again, if it's a whole number times a radical, you multiply the ones on the outside. So it's -7i root 7. Okay, I like to do that inside one first. Now I'm going to go to the outside. So 3i times root 63, which I'm going to keep for now. And then the last one, when I'm multiplying a negative and a positive, it's going to be negative. 3i times I is 3i squared, and then I'm going to keep that root. Okay, and then the last thing we're going to do is simplify and combine like terms. Okay, so I have to simplify the square root of 63. Most of you know what the perfect square is in 63. What is it? 9. Okay, so this is root 9 times root 7. 9 times 7 is 63. So we're just going to write this as 3 root 7. And I write it inside the parentheses just to remind myself. I don't try to do too much because I am very visual. I like to see what I'm multiplying. So then I have 21 root 7. Okay, I have no radical to simplify here. So I'm just going to leave it as 7i root 7. Okay, and again I have root 63. So I just simplified that into 3 root 7. Again, like I said, I'm visual, so I know I'm going to make less mistakes if I write it out and then multiply, because there is a lot going on in this problem. And then that I squared, I know I need to plug in a -1. So -3 times -1 is going to be +3. And now we're going to remember back to chapter 1 about what radicals we can add together. You guys remember? They have to have two things the same. Yeah, they have to have the same root and the same number underneath. So if you have the square root of 7 and the square root of 7, you can add the numbers in front. So 21 plus 3 is 24, so this is 24 root 7. And then for these, I can add them together if they have the same variables because they both have root 7. So 9i minus 7i is 2i root 7. Okay, and then it should be in this order, and again, that's because we want it in that a plus bi form still. So this is the real value. Okay, this is the imaginary value. And it's okay for the bi form to have that I in front. Okay, you will see the textbook does that too. It's so that nobody puts the I accidentally underneath that radical. Okay, so the I can go in front there. All right, so we are problem solvers in here. You have a lot of skills. You have a lot of skills that you've been building up over the years, right? So I want you to use those skills to find all solutions of the equation and express them in this form. Okay, think about how you're finding solutions. What can you recall about solving equations that look like this? Okay, and then I'll just come around and check and see how you're doing. Just make sure you show your work, okay? Okay, so there are multiple ways to do part A. The quickest way is just going to be to move over this 16. But what type of equations are both of these? They're both what type of functions? Yep, they have x squared, right? They're quadratic. So with quadratics, we factor. If we can't factor, we quadratic formula or completing the square. If you don't have a trinomial though, you can just move it over and square root. Okay, but some people forgot one key thing when you take the square root. What do you need? Plus or minus. So plus or minus, and then this would be 4i. Okay, because it's I root 16, and then the square root of 16 is 4. Okay, and then I know that a couple of you have factored with imaginary numbers before, right? Some of you done that? Yeah, I had a few people too. So if you are factoring with imaginary numbers, you can do x minus 4i, x plus 4i, and then solve it from there. That would be fine. All right, but if you can't factor, which there's nothing that multiplies to positive 3 and adds up to negative 3, so then your options are the quad formula or completing the square. You get the same answer either way. Okay, I am a quadratic formula person, but I really feel like they both take the same amount of effort in this case. So the opposite of b plus or minus b squared minus 4ac. Okay, whenever you see a quadratic, you should be thinking factor, quadratic formula, complete the square. If you have imaginary numbers, okay, if they're telling you to write it in that form, you can just go to the quadratic formula or completing the square. Okay, that is fine. So you have 3 plus or minus, this is 9 minus 12. So you got negative root 3 inside. So I root 3, divide by 2, divide by 2. Okay. And you should always have two solutions. Remember what we just talked about in our last section? 3, 4, whatever the degree is, that's how many solutions you have. And then if you want to complete the square, you would just keep your x values on one side, plus blank, move that 3 over. If you do half of this, it's negative 3 over 2 squared, which would be 9/4. X minus 3 over 2 squared equals, get your common denominator, you have negative 3 over 4, square root, plus or minus I root 3 over 2, because you square root the top, you square root the bottom, you move it over, and you have the same thing. All right, so I also just wrote a little reminder here, include the plus or minus when you take the square root. Okay, so you want those two answers there. All right, I'm going to give you time to work on your homework today.